Uh-oh, I think I blew it up. Alrighty, if you're watching this video, you're either a fan of my channel or you accidentally hit full send on your battery discharger just like this, angried the little pixies inside, let the magic smoke out, and it went boom. Alrighty, just like I said in the intro, if you bought one of these dischargers from eBay, Amazon, AliExpress, or Alibaba, it doesn't really matter where you bought it from, it's like 40 or 50 bucks. They work great when they work. However, if you don't follow the directions or if you don't turn the knobs down when you're done or before you start the discharge test, depending on the battery that you try to discharge, you will blow it up just like I did. Of course, I didn't get that on camera. I tried it with the Husky battery a few months ago, and I'm just now getting around to fixing it. You actually have 3 options to repair this thing. Is 1, get a new one for 40 or 50 bucks. 2 is order some super cheap MOSFETs off of Amazon. These ones cost 10 bucks for 5, or you can spend just a few more dollars literally and get the real thing from Jameco or DigiKey or something like that, and just get the real one. I think I paid $15. Let's get to it. Alrighty, so the tools and items needed for this repair: you're going to need a soldering iron, doesn't really matter which one. You're going to need some solder, technically doesn't matter, but electronic solder would be ideal. Solder wick or a solder sucker, doesn't really matter which one. Obviously, you're going to need some either super cheap MOSFETs or the real MOSFETs. I would go with the real MOSFETs, and I'll show you why in just a little bit. You're going to need some thermal paste, doesn't really matter which kind. I just had this stuff on hand, so that's what I'm going to be using. And some flush cutters or some diagonal cutters or cutters, whatever you want to call them. And that is pretty much it. Alrighty, step 1 is removing the heatsink, and all you do for that is pushing down on the little lever right here, and it should come right off just like that. And just give that a little tug here. Alright, so here is the MOSFET that we're going to be replacing, and all we really need to do is heat up the legs down here and remove the solder. And you could either use the soldering wick for that or the solder sucker. I'm going to attempt to use the solder sucker since I don't have much of the wick left. It just sucks all that solder right inside. And depending on how much solder is on there, you may have to do that, once or twice. I guess right here would be optimal if you had more of the solder wick, because then you could wick the rest of it out. I don't have very much left, but we'll give it a try. There we go. Don't know how well this is going to show it, but you can see the part number right on there. And I was just looking at the side, and there's a crack right there along the side. So this one definitely went boom. And at this point, you could technically remove the rest of the solder if you like, which I'm going to do. Get them nice and clean. Next thing we're going to do is just kind of wipe this off with some rubbing alcohol. Hopefully the reflection isn't too bad, but there you go. All of the solder is removed. There's a little bit on the back side, but that doesn't matter. Nice and clean for the next MOSFET. All right, we're gonna skip the Bojack for this, the cheap ones, and we're gonna go right for the real thing. I can hold these up next to each other just so you can take a look at, a real one and a fake one. Maybe there's a difference, maybe there isn't, I don't really know. All right, the one on the right is a real one, and the one on the left is the cheap one. I guess the little holes are in different locations, but that's about it. Alrighty, here's what we're gonna do is just hold it down in the center, and we're just gonna push each leg down. And there you go, just like that. And then cut the legs off, roughly right there. Alright, next step is line up the hole on the MOSFET with the hole on the circuit board. Or close to it. Next thing we're gonna do is solder on each leg. Now, the first one that you do is probably gonna start pushing this around, but that's okay. We'll go ahead and get the first one with solder, and then we will move it to the correct location and then let that solder dry. Actually, I could leave it there, but I am gonna scoot it over just a hair. Just like that. And let it cool off a little bit. Now you can do the other 2 legs and it will stay right where it's at. Obviously do this in a well ventilated area unless you have a fume extractor. All right, there you go. MOSFET replaced and all cleaned up. And we'll set that off to the side and we'll grab the heatsink and fan because we're gonna clean off the old thermal paste real quick so we can replace that. And then you can just use anything to get that off with a little bit of alcohol. Alrighty, the next step is thermal paste, whichever brand you have. And just a little dab will do ya. And you could either keep it right in the center or spread it out a little bit. I'm just gonna spread mine out a little bit. Alrighty, last thing to do is put the heatsink or fan back on. So on the top side, you have the little like thumb presser on one side and nothing on the other side. All we need to do, latch one side, set it in place, push down, and latch it in place. All right, there you go. One hook on this side and one hook on that side. Last thing to do is hook up the fan. And I just kind of tuck the wires in around the side. Boom, and done. That was seriously like a 3-minute repair. Anybody with a soldering iron could do that. So the next thing we need to do is hook it up and make sure it works. Now, before I blew it up the first time, I could discharge around 24.5 amps. With the correct MOSFETs, you should be able to do the exact same. However, if you use the cheap ones off of Amazon or the cheapest ones you could find, like I did the first time around, it'll only discharge around 16.5 amps. I'm not sure why, that's just what happened. So I'm paying twice and you guys should only pay once, hence the video. Alrighty, so before you guys use this again, I would take a look at the instructions again because in 2 places it tells you to turn down these knobs. In the instruction for connection and operation, kind of poorly written, but anti-clockwise rotate the 2 current knobs to lower the limit. All right, and then over here there's a warning. The 2 current knobs should be set at the lower limit before using. Counterclockwise, adjust to the end double current knobs to 0 amps, then increase the current slowly. What that says in English is make sure these 2 knobs are turned all the way down before you plug it in and start your test, because if they're full send, you're gonna blow it up. All right, so what we're gonna do next is test this out and make sure it works. We're gonna be testing this out on a lithium iron phosphate Navitas cell from Battery Hookup. These are 3.2 volts nominal, 25 amp hours. Not that that matters. They're probably not even full charge right now either, but that's okay. We're just doing a quick little test. Alrighty, just like the instructions say, make sure the knobs are turned all the way down. Obviously make sure you have your battery hooked up and let's plug it in. Awesome, so the power does show up. We're sitting at 3.2 volts. Let me reset this. I'm not gonna do a full discharge test. We're basically just gonna test it right now. So we have a coarse knob and a fine knob. All right, here we go. I'm gonna start with the coarse knob. We'll turn that one all the way up and we're sitting right around 20.4. And if we turn the fine knob up, and we're sitting at 24.4, which is fan-freaking-tastic. Boom, and you're done. Alrighty, there you go. The 150 watt discharger tester thingy is fully repaired. So don't go out and buy the cheapest MOSFETs that you can buy. It'll work if you really want it to. If 16 amps is enough for you, you can get the cheapest ones. If you want to restore it to its maximum performance or whatever, make sure you go to Mouser or DigiKey or Jameco or anything like that and just get, you know, a real one. It'll save you time and money. Time is money. Alrighty, well that is pretty much it. I don't think I could waste much more of your time. That's a lie, I probably could. Alrighty, there you go. That is pretty much the end of the video. I think it was a successful repair. If you thought this video was helpful, make sure you like the smash button. Don't forget to like, comment, and subscribe. And I will see you on the next. And I dropped my screwdriver. Which one's positive? Shush, you.
Which one's positive?
You can't see them. It's so tiny.
Isn't that like the most important part of your job?
Yeah.